Hi everyone, welcome back to another Q-Learning Survey project update. It's been a little while since the last formal video update, but project has not disappeared. We just had a short thesis revision side quest. This update is slightly different. It is partly a series research update, partly a project coordination update, and partly a survival report from my thesis defense. The main topics today are Hamna's compatibility verdict slide deck, Logan's continuous control markdown memo, and how this fit into the next stage of the survey. If you recall, the last formal update was on July 31st, then I disappeared for a bit, not because the project died, but because thesis-revision became the final boss. So the final official explanation is the project was not dead, it was merely buffering. During this gap, Sagner's work still continued. Hamna pushed the benchmark comparability argument forward, Logan produced a very substantial continuous control memo, and I survived thesis defense and revision. So now we are back to survey mode. Before the project update, I'm gonna explain the side quest. My defense was a 20-minute presentation, followed by 1 hour and 20 minutes of questions, followed by 45 minutes of deliberation. So basically, the presentation was the tutorial level, the Q&A was the boss fight, and deliberation was the loading screen where you question all your life choices. But it is done, I survived, the thesis has been revised, and now I can return to the Q&A survey with a slightly stronger mental mode and possibly a slightly damaged soul. And now back to the actual project. There are three main pieces of progress. First, Hamna's work on the comparability verdict. This connects the coverage heat map and protocol metadata into the argument we need for section 5a. Second, Logan's continuous control memo. This is a large technical markdown document organizing Q-learning for continuous control around the argmax problem. Third, from my side, claims verification and project integration and continuing now that thesis revision is finished. The common theme is that the project is moving from scattered nodes and individual artifacts into structured arguments that can actually become paper sections. And now Hamna's key point is very important. Just because two algorithms report results on the same game does not mean their scores are directly comparable. There are two conditions. The first is structural coverage. Did both papers report the same game or same category? This is what the coverage heat map answers. The second is protocol compatibility. Did the papers use comparable evaluation protocols, sticky actions, frame budget, termination rules, seeds, and whatever? This is what the protocol metadata table answers. Most surveys implicitly check the first condition. Very few explicitly check the second. This is exactly where our section 5a can make a stronger methodological contribution. And the rainbow example is the concrete proof. In the original paper, the evaluation used no sticky actions and best checkpoint scoring. In a re-evaluation under the Mercado scale protocol, sticky actions are enabled and evaluation window is fixed. The algorithm did not fundamentally change, but the reported numbers changed meaningfully. So this is not just a formatting issue or a metadata issue. Protocol differences can actually change the conclusion. This means when we compare DQ error scores, rainbow error scores, and later Atari scores, we need to be careful. We can still discuss them, but we should not pretend every number lives in the same experimental universe. And now the section 5a formula should be heat map plus protocol table plus verdict table. And this is the simplest way to summarize Hamna's contribution. Coverage heat map plus protocol table plus verdict table equals the section 5a argument. The heat map tells us whether the comparison is structurally possible. The protocol table tells us whether it is methodologically compatible. The verdict table turns those two sources into a conclusion. Comparable with caveat, not directly comparable or missing data. So section 5a is not just a benchmark summary, it becomes an evidence map for what comparisons the survey is allowed to make. And now Logan's memo. The central idea is beautifully simple. Continuous control Q-learning is organized by the argmax problem. In discrete action spaces, the greedy action is easy. You enumerate the actions and take the max. In continuous action spaces, the action set is untouched and uncountable. So the Bellman backup asks us to compute a maximum that generally has no closed form for a neural network. So continuous control Q-learning becomes a story of how people approximate, avoid, structure, or delegate this argmax. That is a much cleaner organizing principle than just listing methods chronologically. And Logan organizes the area into 6 families. The first is structured or active-free maximization. Can we make the maximization analytic, discrete, solver-based, or otherwise tractable? The second is critic stabilization. Once you have a critic, how do we stop it from exploding, saturating, losing plasticity, or becoming miscalibrated? The third is offline value learning. How do we avoid unsupported actions when learning from fixed datasets? The fourth is offline to online transfer. How do we fine-tune without destroying the pre-trained critic or policy prior? The fifth is expressive policies with value guidance. How do the diffusion of flow policies use Q values? The sixth is safety and reachability critics. What does value learning mean when the goal is not just reward maximization but deployment safety? This is too large to paste directly into the paper, but it gives us a very strong source document. The integration challenge is that continuous control should not be forced into an Atari-shaped box. For Atari-style DQN, the question is often which weakness of discrete action QLearning does this method address? For continuous control, the first order question is different. How do we compute or approximate the continuous action maximization step? Then offline IR, generative policies, and safety critics become different ways of handling support, proposal distributions, scoring, or deployment constraints. So the plan is to treat Logan's markdown as a technical memo and to distill it into a shorter server-facing section, probably one compact taxonomy table plus one paragraph per family. And now the funny part. At this point, the project has accumulated quite a lot of infrastructure. We have a claims verification ledger, we have a markdown to PDF build pipeline, we have a comparability verdict framework, we have a continuous control mini survey, and we have a project lead who recently survived what felt like thesis court. So either we are becoming a serious research team or we are accidentally inventing a bureaucracy. Honestly, maybe both. But this is good. For a survey paper, structure matters. The challenge is not just collecting papers, the challenge is knowing what claims we can safely make, how comparisons should be interpreted, and how new areas fit into the taxonomy. The next step is clear. First, we need to turn Hamna's verdict table into actual Fraction 5a writing. Second, we should ask Logan to produce a compressed version of the continuous control memo, core framing, six family table, one short paragraph for family, and open problems. Third, claims verification continues row by row. The goal is to first identify which claims are correct, which need caveats, and which need fixing. Fourth, after verification, we do the fixing pass, citation issues, year mismatches, protocol caveats, and wording cleanup. So this is the comeback update. The project is moving again, and the CC side quest is mostly done, and survey enters its next arc. Thank you for listening.